Uh, so this is a birds of feather session, which is where we are trying to do the conversation. And if audience has any questions regarding or want to learn about how to develop on Windows on Snapdragon, this is the session. And I have with me Marcus Perriman, who's also leading the developer ecosystem at Microsoft. So anything that's related to learning about how to develop on Windows on Snapdragon, or any questions related to AI, this is a good time to ask. Or Marcus, another thing that we can do is we can just talk about a developer who wants to just begin developing on Windows on Snapdragon. What's the best way to do it is, and then maybe we can take some follow-up questions from there.
That would be fine. I think it might be good if anybody does have a question, something a topic they want us to cover. Then if you want to suggest something, we'll pick it up and we can run with it. Is anybody here actually developing a Windows application today, or a Windows driver? Is anybody doing anything with Windows? Do you know what Windows is? And in terms of your interest in this session, what areas should we dig into? Just a general awareness, is that sort of the stuff? App development, hardware, what level do we go at? Anything?
I'm very curious about hardware, but it sort of answered it here as Windows on Snapdragon, which makes it very specific. I've seen you spoke in the fireside about form factors. You talked about development boxes, some from Microsoft, some from Qualcomm. Current set of client devices, laptops and tablets and things. Is there a workstation form factor that either exists that I'm not aware of, or that is being discussed?
So currently we don't have a workstation format because is there any specific apps that you're looking to run? Because again,
so I'm coming here from the hardware vendor side of things. I'm from Ampere, so we're
okay.
Silicon vendor side, and there's interest in Windows, but there's I don't want to get into the whole licensing thing here, but I'm just curious about the interest that you may be seeing for larger form factor desktop workstation.
Yeah. So we identified there is a gap, and we also are aware of the demand that's in this space, especially with the ARM-based processors. But Qualcomm currently is focusing more on the consumer side of things right now. So we haven't been really focusing on the commercial yet. Could be in the roadmap, but as of now, we are more on the consumer side of devices.
So from a demand perspective on Windows, we've got people asking for that sort of form factor, and from a Microsoft perspective, there's no reason why we wouldn't see that as a target. If somebody that's in the commercial space sees it as a commercially viable option, then we go for it. And
maybe we should talk.
The challenge is that we are, so today no Windows on ARM device that we ship runs any other hardware than Snapdragon. Right. And there are reasons behind that. Yeah. So partly because it's a great partnership, great chip, great IDs. So going into some other space is probably a more complicated question than just is there demand. But I don't see why we wouldn't do that. And we tried it with a little bit with the little puck.
Yeah.
And that it stopped because of market issues. It stopped because of technical issues. So fully open to the idea. In fact, I'm allowed to say this. If I could pick a workstation, one of your Ampere boxes with like 20 cores in it, or in fact far more, 64 cores when I looked at. Unfortunately, we don't license on that, so that isn't ideal for us, and it doesn't have the NPU and the various other system-on-chip components that our client apps actually, we're encouraging them to make use of. But in principle, it's no problem.
So I'm curious about the different computing unit usage on Windows, right? Because you mentioned here leveraging CPU, GPU, and PU. I think heterogeneous computing can be important for the smart devices. So I'm just wondering, in current Windows ecosystem, so what kind of application applications or maybe models are suitable for CPU or GPU, and what other scenarios we need to use NPU. So I'm wondering how such kind of insights from your side for Windows on Snapdragon.
Sure. So I'll start off and then maybe you can add two things if I've missed any. So, look, CPU, GPU, and NPU are all designed for different purposes, to be honest. So CPU is more of a linear task, GPU is parallel task, and NPU is designed specifically for AI workloads, right? The reason you would want to push things on the CPU side or on the GPU side is if the application of such demands. For example, gaming, it's pretty clear that you want to run on the GPU because of the parallel processing it offers. But especially if this is a complete control of how the applications run or which applications to execute, then CPU becomes your primary task. Now, coming to NPU, it's an evolving space. I wouldn't say all AI applications run perfectly great on the NPU, but that's where we are all heading to. Today, you asked about the workloads. So when it comes to workloads, the traditional AI and the Gen AI. So there are two things right now. So the traditional AIs run extremely well on our NPUs because of the architecture it has been made. So Gen AI LLM space is something new that we are continuing to invest on. Today, you can still run some of the latest and greatest models like Llamas and Qwens and DeepSeeks, and they are enabled through our AI partners like Ollama's LMStudio, anything LLM, or you can use Onyx Runtime or even QNN, which is a native Qualcomm tool. So there are different ways in order to access to the NPU and run different kinds of AI workloads. And one more thing, we also have AI Hub where some of these models are quantized and is being put up like a model zoo where you have multiple models that you can go and download it. So in a nutshell, each of them have been designed for a different purpose, and the models, new models are coming out every day, and the architecture is being kept in mind to make sure that the older models as well as the newer models are being supported.
I'll add to that a little bit. So you asked about size of model. I'm not sure I'm qualified to know where the division is, but the consideration we've got, we're pushing most things that we do as AI on the device to the NPU. For example, Silica. The key reason for that is power. So the power consumption of the NPU is significantly lower than actually throwing that onto either GPU or CPU. But then there is a situation where CPU makes sense. And that's exactly what the SME extensions from ARM are targeted at. And Clyde specifically is an area we're very interested in to see how can we bring in newer generations of silicon when we get there. How do we bring those Clyde minimal workloads, and what are they? And I don't think we yet know exactly where that boundary is. Because if we can avoid the cost of spinning the NPU up, then let's do so. Having said that, what we're finding with the Copilot Plus PCs and the models that we're pushing to them, it's becoming almost a constant execution process. The downtime on the NPU is becoming less and less. You think about the way we're doing, I don't know what they call it these days, recall is the original name we gave for the technology. It's constantly running. I mean, there's still gaps, there's still time slices between it, but when you then start to fill that with other AI workloads that are running on the device, I don't know whether there's going to still be a time when it saves spin-up cost of an NPU to running on the CPU. Instead, we'll be looking at sharing the load. So actually then saying that NPU's busy, this makes sense to put on some other piece of silicon, some other compute on the device. Oh, and the last thing I was going to say is where GPU comes into this is training. So this is when we're actually, the work we did on PyTorch, or have just completed on PyTorch, is all on CPU, which is fine, because at the moment on the Snapdragon chip, that's probably the right place to be doing training, which is what PyTorch is doing. Extending that to GPU would be ideal. We know that the silicon we've got in the GPU on Snapdragon is not the fastest for these sorts of things, but it's still capable. So having the ability to span loads between at least CPU and GPU is quite important get developers able to use the maximum amount of these devices.
Okay, yeah, thank you. So another angle is about the ecosystem perspective. So because for CPU, GPU, right, from application level, it is flexible for programmability, right? So but for NPU, it is some kind of a dedicated function, and maybe it is not easy to program, right? So I can see, for example, two facts in the market now. So for example, for some x86 counterparts from Intel AMD, actually they are using more on GPU side to do some AI stuff, right? So this is one thing. Another thing is from Android space in the NPU enablement, you can see that actually, although NPU was introduced early in maybe 2017 or maybe around that time, but actually most applications are still using CPU, GPU,
Yes.
not NPU, right? So how we can solve such kind of things moving forward from the Windows application ecosystem to leverage, for example, the high power efficiency of NPU moving forward. Yeah.
If I just jump in on that one. You're absolutely right. What we're finding with some of our existing partners that are bringing AI into their application, whatever shape it is, the resistance to NPU is quite high. Because they're saying, I've got to do the job twice or possibly 3 times. And that is a challenge. And I don't know if the industry's got an answer for that. Certainly Microsoft doesn't today. We started to look at DML, DirectML, as a possible way of at least softening the challenges around this space by providing a single instruction set in DML with multiple providers to deliver that. So the choice can be made a little easier. It still wasn't a runtime choice to be able to do that, but it's getting towards that point. There's a lot of reasons why we've invested in DML, and the Onyx runtime is the direction that we're going right now. But still, we're trying to bring that in direction in a new technology we're investigating around the Onyx runtime. So today, there's no answer for that, and it is literally 20 flavors of NPU, 20 CPU, GPU, whatever it is. You need to do it 20 times. So the CPU is the common ground, and that's why folks are staying on it.
Yeah.
Is that going to continue? I don't think so. I think there's going to be a time fairly soon where people have to get onto the NPU in order to get the loads. The CPU is going to be through the sky.
Yeah, especially for laptop, right?
Yes.
Battery life is important.
Battery life, yeah, exactly right.
Yeah.
So we, the onus is on us, on Microsoft and the industry. Probably, hardware vendors is part of this as well, is to figure out how we do this it's not quite heterogeneous, but it's towards that, more like that, in a better way, so software developers are not limited.
Okay.
So yeah, and it's a good point, and it's a challenging area.
Yeah, your answer is very good.
Yeah, no, I think Marcus did point out some important points there. DML was a great equalizer, right, when it was there, and basically what it does for graphics is what we expect it to do for NPU. But I think Microsoft, I think there are some solutions that we are all working towards having that common API, so that all you need to do is just choose the device and you don't have to change the whole stack, right? That's the developer ease that we are looking for. Your question on the phones, yes, there are a lot of apps today which are not leveraging our Hexagon NPU that are present in the phones today, but that is also to do with a lot of Android Studio, where people identifying some of these workloads and saying, hey, this is what is good at NPU, CPU, and GPU, right? So there is whole ecosystem push that we are trying to do, especially with the NPU, and eventually you will see that, and even in the mobile space as well as on the compute space. But I think we're all trying to find that one equalizer where it's just easy to offload onto the NPUs. I think that's going to solve a lot of problem in the future for us.
Okay, yeah, good, thank you.
Any other questions?
I'm not in this field, so I wonder what is the hardware capacity of the NPU on Snapdragon, let's say, compared to like NVIDIA, like what
Yeah, go
I mean, I'm going to talk about Qualcomm hardware here. So Qualcomm's NPU has a list capability of 45 tops. So trillion operations a second. Actually, when you start looking at the hardware, it's pretty tricky to get 45 tops on a single model because of the way the different pipelines are set up and everything. But it's very difficult to compare what capabilities are on that type of hardware compared to, say, a general purpose GPU. So if you're looking at an NVIDIA general purpose GPU, they'll have a significantly higher number of tensor cores that are in there. So the number of parallel operations that they can do is significantly higher, but the cost of doing that is also significantly higher. So when you come to the NPU, the idea of actually having very rapid, very low power inferencing is exactly what it's trained at, designed for. So you can run, so we run Phi Silica, which is our Microsoft's internal Phi model that we're using for our Copilot runtime. So that's backing our, I think of the different models. So our segmentation model, it's an API in Windows. There's about 5 different operations we've got that the Phi Silica drives, including language, so it does translation, text to speech, speech to text, excuse me, and various other things. That model is all running on the NPU on a Snapdragon device. Would you run that on an NVIDIA device? Yeah, absolutely, you could. We haven't converted that model for a GPU, at least not publicly. So in terms of comparing its capability and performance, I'm not really there to be able to say, but it fits well within the capabilities of the Hexagon NPU on the X Elite.
Yeah.
Does that help you understand a little?
Yeah.
Maybe you can.
Yeah, I just want to add a couple of things to what Marcus said. Basically, our NPU is capable of running all kinds of different models, right? Like image classification and audio models and image vision models and so on and so forth. So the first place, if you're interested to understand what models can really run on NPU, I would suggest you to look at aihub.qualcomm.com, where we have quantized some of the models and made it available, and you can see what are all the different models. And along with that, we also have a GitHub repository that we maintain of all the models that are enabled. So that also gives you the idea as to what models. So in short, traditional models plus new LLMs, all are supported. All different arrays are supported. And yeah, I think NPU is specifically is going to be the place where you want to run all your AI workloads, because the hardware is designed to be suited for such models, right? Coming to NVIDIA general purpose hardware, you run games, which is designed for games, but then you can also run LLMs. So you're going to use that up a lot, but then again, there's also a power issue that also comes up when you start using multiple applications on your GPU. So NPUs is the exact reason why it's a game changer, because it doesn't touch either your CPU or your GPU, and it's all low power, and all your AI workloads are running on that third chip that's in SoC.
And then another question is about the runtime support. Let's say I download a model from Hugging Face. Can I like use it on PyTorch and Hugging Face? What is the runtime compatible?
Yeah, and so Hugging Face has got models which are available in different quantizations. So one of them, in some cases, there are models available for running directly on the NPU, the Snapdragon NPU. Can you specialize them? Yep, absolutely. So you can download those. You can. There's actually two or three different tool chains that Microsoft provide to help you here. One thing I would advise you, if you're interested in this space, on a Windows machine, go to the Windows Store and look at AI Dev Gallery. AI Dev Gallery. It's an application that was built by my team. That was we sort of realised about a year ago, a bit more, about 18 months ago, we realised that the on-ramp for developers, for Windows developers, is too hard. And actually, we didn't understand how somebody said, put AI in your app. We were what does that mean? How do I go about doing that? So put a couple of devs on it and said, go figure that out. What does it actually mean to add AI to an app? And the application that come up with actually allows you to not only use various different things. So it allows you to go and grab Hugging Face models, and it will list the ones that it's got there. It will allow you to play with them and use them as an example. It will allow you to load your own model as well. So if you want to go grab a Hugging Face model, play with it in PyTorch, and then use it in that tool, it'll let you do that. If you want to use the PhiSilic, the Windows Copilot runtime model, it's got examples of that. And now when you've finished, and it'll also let you run it on CPU, on GPU, on NPU, depending upon what the model is for. And when you're ready, you hit the go button and it will spit out a Visual Studio project with just the code you need to replace or replay what you've just been doing. So you now know, okay, well, you play around and go, yeah, I want it on CPU, I want to do some speech to text, I want to use this model because it works well. Great, now I'm ready, bang. And then you've got your sample, you go and add it into your code base, and off you go. So that's a good place to start, I would suggest, to at least get to understand it. In terms of specializing models, we have something called Olive, which was put together 2 years ago. It's the Onyx Live is what it stands for, Olive. And the idea of the Olive toolchain is that it will allow you to take a Hugging Face model and specialize it with your own data. So you can take it through that chain and it will produce a model at the end which has got your extra tweaks and parameters of it. And it'll give you some guidance. It's a bit more technical, a bit more tricky to set up, but if you know what you're doing, then you can go and get that done pretty easily.
Yeah, no, I think along with that, especially if you want to just get started with AI on the platforms, there are third-party companies that I can mention about, like, Ollama, LMStudio, anything LLM. They use these technologies like Onyx Runtime or QNN in the backend, and they enable directly running models on your platform. For example, if you have heard about Ollama, you can just download a model and just Ollama start chat, and you can start chatting on your device. Today it's been enabled on our CPU, but then we are working with them to run on the NPU, and similarly LMStudio as well. Anything LLM is one tool where they're using QNN in the backend, where they have directly used a Qualcomm tool, so they have direct access to the NPU. So it's a Windows software, so you can just download on your laptop and start using it right now. So you'll see it's using NPU for all the LLM in action.
So, I'm going to make it wake up. Anthony, you said you had some tough questions. There's a gap. Do you want to ask a tough question?
Yes. Why was so there was an issue with the GPU driver on these machines, with the Vulkan GPU driver. What actions have been taken to address the improper release pipeline that resulted in a partial release of the GPU driver?
So V96 GPU driver that we released is our very first driver, right? Like before that, we did some developer preview of a driver, and this is the cadence that we are trying to follow. Now we understand the problem, and this is where we want to understand more of what exactly the Vulkan issue that you're talking about, and see if we can reproduce at our end and start fixing it in the next upcoming driver release. So
I think it's fixed in the beta drivers, but what steps have been taken to stop that happening in the future?
Oh yeah,
Because
so
the issue, as I understood it, was the driver was tested on a machine that already had beta drivers tested on it without it being cleaned in between, which meant that you're only shipping kind of half a GPU driver because it assumed the other part was there. Have you changed your release processes for the drivers?
yeah, so the release process, we now have this exhaustive testing that we are doing right now, right? And we are trying to make sure all the devices in the farm are all tested for these and for different scenarios. To answer your question, we don't want this again, but we've also made sure the certain testing infrastructure has been set up in order to make sure these things doesn't come again.
Okay. And the next question is, when is SPIRB support for OpenCL coming? Because that prevents things like SICK or the GPU acceleration running on
Yes.
these devices.
I don't have an insight into that roadmap, to be honest with you. I would love to give you that answer because I don't want to mislead you as to when it is coming. But you will get to know when we announce it. Yeah.
No tough questions for me.
Yes, but not that are being recorded.
Okay. Okay, we'll pick those up later. So let me ask you a question then. How would I get started with the QNN toolkit to actually go and build some AI stuff?
Good question. So in Qualcomm developer site, there is Qualcomm QNN SDK. So the first step is, of course, to go get that SDK. And we have a lot of samples in that SDK where it directly helps you access the certain CPU, GPU, or NPU as to where you want to run that specific model. So we have this exhaustive documentation as well to support the QNN. So we are making our roadmap on the QNN to make it much easier and simpler for developers to go and access. But I think the place to start would be to check out developer Windows on Snapdragon developer portal, where we have AI development and how you can access the QNN, the easiest way to get started, and how to run a model on our platform. Yeah, thanks for the question.
Thank you.
Yeah.
Have we drained the room dry of questions?
We need more people.
It's 5:45.
What time are we due to finish?
5:55. We have like 10.
So 10 minutes.
Yeah.
So, wants to tell some jokes or nobody?
So I have a question, Marcus. So previously for the Copilot plus PC, so I think the Phi Silica model was integrated by default. It is around the 3.3 billion parameter, if I remember correctly. So in the trend about the size of the model moving forward for native inference for such kind of SLM models. So will it become, for example, 7B or maybe even for 14B?
I'm not sure. Again, I'm not sure I'm fully qualified to answer that because I've probably got the same data that you have. But when I look at it, I'm seeing the models reducing in size quite radically still. And the techniques that I read about in terms of how these models are being folded look like there's still a bit of a way to go. So if I was to use my intuition that we would, when you look at rate of change over time, I'd expect the rate of change to slow before we see these models plateauing out. But by the time we get there, everything's speculation, but it's changing so fast.
Yeah.
By the time we get to a plateau, we're going to find something else. And there's something really interesting, I think that Grant said, or somebody said this morning, is that in 2 years' time, I don't think we'll be using LLMs or whatever. I thought that was quite a challenging statement, but it's probably quite true. That if we are changing at the pace we are, I mean, our technologies we're using today were only seen for the first time in November last year, and they're considered mainstream or must-haves. That rate of change the software industry hasn't seen for a while, and it doesn't seem to be slowing.
Yeah, I think it is maybe some kind of application driven, right? For example, from a hardware perspective, AMD just announced some new chip or platform some time ago. They can run, for example, 70 billion parameter models on the laptop, right? So, but I'm not quite sure about what kind of application on Windows, right? We need to use this size, model size, right? Maybe for some basic things, we just use a 3 billion model is enough. And for bigger one, we can leverage the Azure cloud, right? So I'm not quite sure about this from hybrid AI perspective. So,
but I don't know whether I'm with you in terms of the size. There's going to be an application for each of those models. There's going to be something that people want to do. But the 3 billion parameter model running on is sized to fit on the NPU. It's not a mistake. It's been deliberately tuned to the point where we can actually run that successfully and continuously on the NPU. And that's because if we did it on the CPU, the battery wouldn't last half a day. So we're at that place. If we could run a 17 billion parameter model successfully on an NPU which didn't draw 5 times the power, then we probably would. And then we would find other applications or possibly higher accuracies that we gain from that. But right now, for me, the golden bullet for AI is working out what workflows make sense at a general purpose level and at a specific level. We're looking at conversational AI, and that seems to be, from a business perspective, that seems to be a huge advantage. It's giving almost all roles in industry potentially a 5 or 10% saving in what they're doing. That's massive.
Yeah.
But in terms of what we see as IT in AI, it feels like it's the tip of the iceberg, and we haven't really started. And my question is, the one I'm mulling over is, where do we get to in the specifics of AI for day-to-day usage from a Microsoft perspective of a Windows machine, but potentially in the business process or in the technical process that you're going through for building code or designing something. And I don't think we've got answers for that yet. We're seeing some stuff in the lab today, but actually until it rolls out, we won't know what size of model is going to be required to actually drive that.
And use cases are evolving, right? I mean, it's very early. The way I would see it is, a lot of people are testing some of these models, right? Like many companies are testing phase rather than in the product phase. But then the place to start would be to first understand how it fits into their overall app or product strategy. Test it out, what they want to offer, but then that's where different model sizes come in and what they want to offer with each model size, right? Because every one of these apps, the way I see it is, have their own set of benchmarks, have their own set of responses that they expect from some of these models, right? Like a simple summarization, 3 billion model works, but people want more than that, right? Like coding models or mathematical models, where you need to go a little bit more deeper than just a smaller model what it provides. So I think the use cases will come, but the challenge right now is that, hey, how efficiently am I running? What am I getting out of it, and how can I scale it, right? So that's the way product development people are thinking.
I'll just underline that. I think in terms of where we're going next, investing when we're talking about Qualcomm, at the hardware level, investments in making the NPU capability lower power and bigger, and faster comes with it. It's not going to be a mistake. You just got to keep making it bigger, keep making it use less power, and keep making it go faster. And then we will bring the software industry will bring the models, and the business teams will find the application that will light up on that. We're not at that S curve yet. Not even on this bit, I don't think.
Yeah, so hardware and software maybe glow, maybe together, some kind of wave, right?
Yeah, maybe 5 years down the lane, we'll be able to train, or maybe not, on the laptop. So that's the pace of innovation, is what I was trying to explain.
I have no doubt 5 years down the line we'll be training on laptops. I have absolutely no doubt that that's going to come. I mean, it can't wait. The developer devices are going to get smaller. The question is, can I train all day and all night without plugging it in? And that is down to the hardware manufacturers to go.
A lot of innovation opportunity is there actually.
I would suggest you to think like Moore's law, right? Like every generation, how the CPU and GPU evolved, think about how NPU can evolve. So every generation is going to give you much better results.
Yes, I think maybe it is some kind of in early stage for the whole AI new AI wave, right? Yeah.
I think yeah, I think we're almost done. Any questions before we end the session?
We have time for one more if anybody has.
Yeah.
If not, that's
Yeah.
3 minutes early at the bar.
Thank you.
Awesome.
Thank you.
Thank you, everyone.
Bye.
Thank you. Thank you, Marcus.
Thank you.
Yeah.